Welcome to my JK Multimedia Solutions channel. This video is about inverter load collation and inverter sizing. In a situation where a set of electrical loads is to be powered, making use of a single phase inverter, how is the load collation going to be done, and how is the inverter sizing also going to be done? This is what this video is all about. Usually or always, the electrical ratings of electrical items are always written on them. For instance, this is an LED bulb, a light emitting diode bulb. The power rating and the voltage ratings, they are written here. So that is how we know about the ratings of the items. The rating could be in the wattage, or it could be in watts, or it could be in VA. But in this situation, for the load collation for the inverter, we are going to make use of watts. Alright, so any rating that is given in VA, that will be converted to watts by multiplying it by 0.8. That 0.8 is the power factor. Alright, so that is very clear. However, in a situation where the rating is not written at all, the power rating, if it is not written at all, then the power rating of that particular device could be determined by making use of a clamp meter. This is a clamp meter. These are the leads for voltage measurement in this situation. For the current measurement, so these leads will not be there. So this is a clamp meter. So you open this one to open the current, to measure the current. Alright, and when the current is measured, making use of this method, then we use the leads, we put the leads there to measure the voltage. Alright, so when both the currents being drawn by a particular electrical gadget or item is known, then we can obtain the product of the current and the voltage. When we have the product of the current and the voltage, that is the rating in VA. Then we can multiply that VA by a factor of 0.8. This is what I'm saying. The S, this is the apparent power, which is equal to the reactive power over power factor. Alright, and then this one is in watts, this one is in VA. So you can now obtain the the active power in watts to be equal to S times power factor. Okay, and that is how it is done. Alright, so for this purpose, we are making use of the power rating in watts. So we move on. Please do subscribe to my JK Multimedia Solutions channel and follow me in this video as I make use of an example to illustrate the concept of inverter load collation and single phase inverter sizing. Now, moving on with an example. The electrical load details of a particular residential building are as follows. A. 17 number 15 watt LED bulbs. B. 1 number 200 watt fridge or refrigerator. C. 1 number 200 watt freezer. D. 1 number half horsepower borehole pump. E. 3 number 65 watt laptop computers. F. 5 number 12 watt phone chargers. G, one number 300 watt electric iron. H, one number 750 watt bread toaster. I, one number 300 watt blender. J, four number 90 watt ceiling fans. K, one number 400 watt washing machine. L, one number 100 watt TV set. M, TV decoder and Wi-Fi system 50 watts. That is the power requirement for the decoder. So this is a washing machine. So now we move on. Given that, these are the questions. Given that the above building electrical loads are to be powered by a single phase inverter, calculate total inverter load. 2. Hence or otherwise determine the required inverter power rating in kilowatts and kVA. Take power factor to be 0.8. Those are the questions. And looking at this place, we can take this one as the summary of the question here. We have the diagrammatic representation of what the questions are saying here. So this is the inverter, and we have the inverter DB, which is a dedicated one. We are going to talk about that one in subsequent videos. Alright, so and then these are the listed summary, the summaries of what we have here. Now, solutions to the problems. Here, this is the diagrammatic representation of what is going on here. This is the inverter, and this is the inverter distribution board, which is a dedicated one. Then we have the inverter loads, and this is the summary of the question. Now, let's look at the solutions to the problems. We have 17 number LED bulb, each of them rated 15 watts. So if you multiply 17 by 15, it will give us this. So similarly, the fridge will give us 200 watts, freezer 200 watts, half horsepower borehole pump, 1 horsepower is 746 watts. So you divide the 746 by 2, it will give us approximately 380 watts. Then we have the laptop computer, 3 of them will give us 195. Then the charger, 5 of them will give us 60 watts. One number 300 watt. What do we have here? That is the electric iron. So it will give us 300 watts. Then we have 750 watt bread toaster. So that will be 750. Then 300 watt blender will give us 300 watts. A ceiling fan, 4 of them, 360 watts. Then we have washing machine, 400 watts. Only one will give us 400 watts. TV set, 100 watts, and the decoder, as well as the Wi-Fi system, consuming 50 watts. And the total load in watts is 3,550, while total load in VA is approximately 4,438. Now, the second part, that is the second question. Total load is equal to 3,550 watts. Then we take into consideration losses in the inverter itself. If we are to get this amount of power going to the load, then and the efficiency is 90%, then the input to the inverter must be 4,000 watts approximately, which is 4 kilowatts. And this is how it's calculated. You divide one has to divide the this power by 0.9, which is the efficiency, which is meter. That is the symbol for it. Now take power factor to be 0.8. If you divide the 4000 watts by 0.8, then we have 5000 VA or 5 kVA. Now the required inverter power rating is equal to 4000 watts, which is also the same as 4 kilowatts, and we can choose hybrid inverter. Later on we talk more about hybrid inverter, and also we can have it as the rating could be 5 kVA hybrid inverter. So it's either 4 kilowatts or 5 kVA. So the two actually mean the same kind of specification. So, and that is it. Finally, please do subscribe to my JK Multimedia Solutions channel and expect more exciting videos. Thank you very much.